All right, I'm going to go ahead and get started. So today we're going to be talking about something that is not exactly SQL, although I will use some SQL in here because, after all, this is SQL days. But I will be talking about Azure Databricks. How many people are familiar with Databricks at all? Okay, one person? Great. Well, then you're in the right place because this is supposed to be an intro class, and people who walk in here and know everything about Databricks, they probably aren't going to learn a whole lot. So just wanted to start out with that. Wanted to make sure to mention the sponsors here at for SQL Days. Without the sponsors, this wouldn't be possible, so please visit them and say nice things to them. All right, a little bit about the agenda. So we're going to talk about Databricks, obviously. That's why you're all here. And a little bit about its history and how it works with Spark. And then we're going to be talking about the machine learning use cases for Databricks. I was talking to somebody who had one of those client engagements where they somebody read an article that had all the buzzwords, and they decided that they needed all of that. And she was telling me, she's like, well, I don't know why you'd use Databricks anyway. And I'm like, I can tell you why you would use Databricks. And so we're going to get into what that is, so know when you want to use it. Then we're going to walk through a little bit of some coding applications so you can see it in action, and then how you might implement it in production. All right, I'm still failing presenter mode. You know, this is why I should never get new pointers. All right, a little bit about me. My name is Ginger Grant. As you can tell from the accent, I'm from America. I talk just like television. I am on Twitter way too much at Desert Isle SQL, and I blog at the Desert Isle SQL website. I am a Microsoft MVP and a Microsoft certified trainer. So I do talk quite a bit, and if you want to get a hold of me, that's my contact information. All right, with that boring stuff out of the way, what is Databricks? So Databricks is not a Microsoft product. It is on Azure, but it is also on AWS, and it was designed to be another implementation of Spark. Spark was designed to make HDFS go faster. So we'll kind of do a little bit of a backstory here. But the purpose of doing things within Databricks is because you've got a lot of data, you want to run a lot of processes on it, and you want to be able to scale it. So because it's cloud only, you can scale it infinitely, depending on how big your wallet is. And it also provides a collaboration area so that you can work with people rather than by yourself in your own silo. So it's more designed for a corporate environment. And it's very, very scalable. There isn't anything that you pretty much can't throw at it. All right. A little bit of the history of Databricks. I don't know how many people heard, but there was a contest that was held a number of years ago to determine who could make a better algorithm for Netflix. So the goal of this contest, which they held, was to see if you could come up with a better algorithm for picking movies. And it was a big contest. The winner won $1 million, and the person who won, I believe they're working at Google now. They were working at Facebook, and they got amazing jobs after that. But there were people who lost, created Databricks. So, you know, hey, becoming in number 2 worked out well for them. But the idea, the reason that they created it is that they wanted to take data in an HDFS, which is a Hadoop format, and process it very, very quickly. So the idea being is that they could take, you know, raw data, split it up into little parts, process each one of those parts independently, put it together, and have it run very quickly and without having to do a whole bunch of underlying MapReduce code or anything like that. So when that process was created originally, that's what Spark was for. Well, the guys who created Spark, the guys who worked on this Netflix context, they were at UC Berkeley, and they wrote about 80% of the code that was in Spark. And like every other development project that I've been on, you get done with it and you're like, I could make that better. I could so make that better if I had, because, you know, hindsight being the only exact science, you think of all these things after you're done that you wish you would have put in there. And they thought about that, and then they thought, you know what? Making money's nice, because Spark is a open source project, which is really, really great that you can use it for free, but that means that none of the guys that worked on it can afford their Silicon Valley apartments, so they decided that they wanted to actually create a product this time. And so they decided to create this new framework, which was based on Spark, And that's what became Databricks. And the idea was is that you could parse things for very large data sets. Give you an example, I was doing some work for an insurance company 2 years ago. And insurance companies have been using machine learning processes, for a very long time because that's how they determine all of their rates. Well, they have a bunch of code that they wrote in R, and what they were doing is they would run their code on Friday and hope to heck nothing bad happened over the weekend, because that's how long it took to create the job. Because it was a huge data set. They were looking at trying to determine rates for the coastal areas if a hurricane hit, for example, and that's just how long it took to process. But the idea being, if you're doing that kind of work, you want to be able to scale up so that you can throw a lot of machines at it, so you don't have to wait the weekend to see what your results are going to be. And that's really what Databricks was designed to do. So the guys who created it first rolled it out in Amazon's cloud. It was released in 2018, and then it was added to Azure in March of 2018. Now, one thing that was kind of interesting about it is that if you look at Microsoft's product line, you'll be like, well, they kind of had something that already did this. And what they had was uSQL. Going against Data Lake, which functionally processed this, doing the same thing. The little teensy-weensy problem with there is not a whole lot of people liked writing uSQL, and as a result, Databricks became widely more popular than Microsoft's products that they created to do the same thing. And as a result, Microsoft has, what did they say? No longer devoting any resources, I believe is the correct term, to the uSQL product, because instead they are moving more with Databricks, because that's where a lot of the development work is being done, where people want to do it, including people who work for Microsoft. One of the coolest things that I have seen done in Databricks was a really cool machine learning task that Microsoft did to find snow leopards. They worked with a nature organization who has a whole bunch of cameras in the Himalayas. And what they're trying to do is process through all the film and develop, cognitive services so that you can figure out which frames the machine leopards are in. And to do all of that analysis, they use Databricks. So internally, they use it as well to, do massively huge projects themselves. They have said that they will support whatever data you want to. You just might need to call them if you want huge amounts of data. All right, so what is Spark? So Spark is what it's based on. So if you are using Spark or know somebody who has, this is just a different little flavor of it. But it's a method for reading data simultaneously. Obviously, that is something that you want to do, multicasting your data so that data can be read not serially, but in parallel. And with using the underlying architecture, what they do is they create a underlying framework that they put the data into. And it's a modified HDFS format. And once the data is in that format, then the code knows how to break it up behind the scenes. You don't have to do all this. The code knows how to break it up into bits that can have data processed on each one of them. So if you've got, a terabyte, it might bust it up into 100,000 pieces, process each one of those all at the same time, and then put them together at the end. So that's why it's fast, because that's the underlying architecture that it does. In order to do that, though, whatever data that you have, it takes it and puts it into that format so that process can be applied. What that means is that you're never really going to be, if you want to use data from SQL Server, you can, but know that whatever data that you use is going to be modified to put in that format to then have Databricks run on top of it. So what it does is it reads the data and caches it into memory. And when you're doing that, it's very easy to do that if you've got to do the same thing over and over and over and over again, and you just want to do it a lot. That's the best use case for it. If you want to do a very complicated process that has huge numbers of steps, all dependent on one another, then it's not so good. But for machine learning, you tend to use the same algorithm over and over and over again on all your data, which is why it's a very good tool for that. It also can handle streaming. So if you want to stream data at it, it'll handle that just as well if it will in batch, just depending on what you're interested in doing with the data. So machine learning, generally speaking, does use an iterative process for applying algorithms. One of the things about Databricks, though, is this isn't the neatest magic cool thing that you have to use all the time. Because it is in Azure, it will cost you money, but there's nothing that means that you can't do some of your development work somewhere else and then migrate it to Databricks. For example, if you're writing machine learning code now and you're running locally and you're just doing some Python or doing some R and you think you got a model going and then you want to throw all of your data at it, that's when you could migrate it to Databricks. So it doesn't have to be the only place you're doing your development. You're not tied into just using it there. But it offers some flexibility if that's where you wish to use it, but you don't have to use the environment within Databricks to do your coding. Machine learning was just a preview feature that they added in Databricks. It's created to help monitoring machine learning processes, and so it's something that they've just added. It's kind of an add-on feature to it, and it works with R, Python, and Scala. And the idea being is that it monitors the running of the models over time, and that's what they added it for. So with Databricks, you can create analytic solutions with it. You can do SQL with it, even T-SQL if you have the right library, because underlying what you're using is you're using Python, R, Scala. And the thing about those languages is they use a number of libraries. And with the proper library, there's many, many things you can do. It also internally does data visualization. How many people here have played with Azure Data Studio? Have you guys messed with it yet? You know that feature that Azure Data Studio has where you can pictorially represent your data by just clicking on it? It does the same thing in Databricks. If you don't know what I'm talking about, you really should start looking at Azure Data Studio as well because it's a cool product. And it's funny because it contains elements that this product does because Databricks is kind of where things are going. So not only does Azure Data Studio have that tool, but Azure Data Studio now also has notebooks, which is how you develop code within Databricks, and we'll be reviewing that as well. It has multi-language support. And a lot of different libraries. When you are writing code in R, Scala, and Python, they use libraries to allow encapsulating a lot of different functions. And within Databricks, you can do that, and you can also have different libraries for different work groups. So it's a big thing in Python to maybe you don't want to upgrade a certain library because it breaks something, and that's supported within Databricks by using different workspaces. So it is a managed service Azure offering, which means you're doing all of this in Azure. I do like to warn people that if you're doing things in Azure, yes, it does cost you money. No way around that, but there is a free trial that I'll show you so that you can get started with it. One of the strengths that they added to the that Spark didn't have is the security portion of Databricks. So it will use your Azure Active Directory information. So you are securing your application and your data using Azure Active Directory. That means that the tenant that you have it loaded in is going to be kind of driving who has access to it. So it does limit the who's able to access things maybe that they're not supposed to. There is a group development environment, and it involves team resource management as well. So you can give different people different rights, again, using AD. It's completely serverless, though. You're not going to see anything. It's never going to be running on a server. I know Microsoft said that about Power BI and changed their mind, but the way this is architected, they can't. This will always be cloud-based, and it's using existing libraries of the Spark and ML as well as the additional ones that they created with Databricks IO. So, all right, you have this thing in Databricks. So, how can you possibly use it? Well, you can use it with Azure Data Factory. For those of you who aren't familiar with Azure Data Factory, it's the way that Microsoft is processing jobs within the Azure environment. It is sort of like SSIS, but it's also a lot like having SQL jobs. So it's the ability to create jobs with steps. So you could create a job, perhaps a step that would maybe take the data in from someplace, like perhaps a SQL server, and then put it into Blob Store, and then take it from there, automatically run a Databricks job when the data is available, and then put the results somewhere else. And that would be the kind of integration that you would do with ADF, but it is not required. When they created Databricks, they designed it to be a fully encapsulated product. So if you just want to run and schedule jobs within Databricks, you can do that as well. Internally, like I said earlier, it puts all of its data into HDFS, and HDFS is the file structure that's used for Hadoop. So you are going to be copying your data into it. It has no access to the Azure cloud internally, but externally, of course, all of your data can be stored in Azure, and you can access it through Databricks. And it's considered a pretty secure environment. So how you write code is, again, a way that the industry is moving to, because you can write SQL code the same way using Jupyter Notebooks. Jupyter Notebooks are originally created as IPython notebooks, and it's just a development environment. It currently supports, I believe, 39 different languages. So there are a number of things that you can write with Jupyter Notebooks. Somebody asked me recently if that was my favorite place to write Python code. And I said, well, no, because it has no IntelliSense. I like it because you can use, and we'll look at it here in a little bit. I like it because you can write code, then see your results, and then save your results off, and you can document it and you can give it to people. But if you're just learning a language, I like things with IntelliSense because it's easier to deal with. But with having one environment that you can use with anything, that was kind of their goal. So it uses Markdown to format the text. If you're unfamiliar with Markdown, you need to become familiar with it, because that's what's used in Git as well. So as more and more code is being secured through the Git environment, you have to write up all of your documentation using Markdown, and what do you know, this uses Markdown too. So it's getting to be rather ubiquitous. If you haven't learned Markdown, you probably need to go bust out a web page somewhere to do it. So this collaborative environment is included. So it's not an extra thing that you have. It allows the code to be managed and accessed by teams of people rather than one person. This is a departure from a way a lot of the data code for machine learning was originally done, because originally there was a lot of people that had a lot of domain knowledge and were really sharp data scientists, and they just kind of kept all this stuff to themselves, and then when they were done, they threw it over the wall and said, okay, productionalize this. And you can guess how well that worked, which is why they're moving towards moving more data science into collaborative environments and moving them into IT where they haven't been before. One thing that Databricks also includes is a fully managed GitHub environment. So you can check your code in and out through Databricks. You don't have to go out somewhere else to do that. So, again, there's no setup other than you need to create a GitHub repository, which isn't much of anything. One thing that I really like about Databricks is it turns itself off in 2 hours. And because I told you it's in Azure, which means you're going to have to spend money, it's nice that it cleans up after itself. So if you, I can say that I have accidentally left something running over the weekend, and I had to beg my way out of an $800 bill. So it's really nice that for this service, it turns itself off in 2 hours. That's a setting. You can, of course, change it, but I don't. 2 hours is awesome. Generally speaking, if I want it more than that, I can just click the start button. It is designed to auto-scale based on the load. So if you don't want it to auto-scale because, you got a $50 a month Azure bill, you can stop it from doing that. But if you want to consume the resources you need when you need to do it, it will handle that too. So you don't have to always pay for a huge amount of processing and server. You just only pay for the bit that you use. So as far as pricing goes, there's 2 tiers, standard and premium. Premium includes more of the workspace environment. This isn't like SQL where if you don't get premium, you don't have squat. With premium, you get more role-based access, so it's more management and integration. And it has ODBC and JDBC endpoint integration within it, which is not within Premium, so within Standard. So you do have the ability to copy data directly in using JDBC into an HDFS cluster, but you have to pay Premium to do that. And there are also 3 different workload options: data engineering light, and data analytics. Data analytics includes more of the machine learning features that are available that you may not even care about if you're just doing data engineering. And data engineering light is designed not to necessarily write anything, but to do more of the running and management of jobs. And you can try it for free for 14 days. So carve out some time and use it for 14 days, but then you can do it all for nothing. Of course, when they give you the free account, they set you up with a premium one, and you can scale that back. But I strongly encourage you, if you find any of this interesting, then to take a look at getting yourself a premium account. All right, so for Databricks, there's a process in doing it, which isn't necessarily obvious by reading the documentation. You need to create a cluster. That's the first thing that you need to do, because if you don't have a cluster, then you can't do anything with or to your data. So the first step is to create a cluster, then to load data into the cluster. Now you got a place to put it. And then start working on notebooks, dashboards, playing around with data sets, and then implement a solution in runtime, and then schedule the running of the job. So that's the Databricks process. But for machine learning, what you want to do is basically write some R Python code. Maybe rewrite the code in Java, write a web service to implement it, or to migrate the code to use a SQL Server web server. And this was designed to replace all that. And so the only step that you really need to do at this point is to write some R Python code. So I'm going to enough talking about what it does. I'm going to go ahead and show you what you can do with Databricks. I'm going to do what I call cooking school demonstrations, because it does take some time to do some things in Azure, and I don't want to bore you for 20 minutes while we're watching things spin. So I'll show you how to do it and then show you what it looks like when it's all done. And come on, do dual screens now. I'm not good at that. Yay! You scared it. You're obviously very intimidating. All right, to start a Databricks resource, by the way, you can only do one free one, since of course I burnt through my free one. I can't do a free one again. So you only get one. So I'm just going to search for Azure Databricks. And I'm just going to go ahead and add one. Come on, and when I do that, I get the Azure Databricks service capability. So I'm just going to give it a name. And it asks me for my subscription, obviously. Resource groups, just the container that you put things into. So I'm going to, oh, that bugs me that I did that, type that wrong. So I'm going to go ahead and create a new resource group for it. And let's take a look at the locations. Now, as you might guess, with Microsoft features, they're not all in every single data center. There's also a trick for the different resources that are available. So if I pick North Europe, later on, I may or may not have access to the most complicated or heavy resources for my cluster. So different data centers have different clusters, and if you know that you want to use a really demanding load on Databricks, you're probably going to also want to look first to see what location the high-end tiers are supported in, because not all the storage tiers are supported in every location. So I'll show you what I mean later on, but what's kind of lame about this is that you need to know that before you go do this. And generally speaking, you do this, and then you figure that, oh, well, I should have picked somewhere else because now I can't pick the resources that I want. So look that up first when you're doing this, if you're planning on doing really intense data processing tiers. All the basics are covered in every data center, so it only matters if you're doing high-end tiers. And if for pricing, there's standard, premium, and then the trial. This is totally misleading too, because if I selected the free trial, I'll go ahead and create, and then it'll say, oh, no, you can't, because you already did that before. So that is kind of a misleading option for me, because, again, I've done it. Well, it looks like it's working. Anyway, if I did all this and click create and then sat there for 20 minutes, then I would get this. And I'm not going to save my edits. So I get this environment, and it doesn't really do anything until I say launch workspace. And it's signing me on to Databricks using my Azure AD credentials. And it'll log me into this environment, unless I've really pissed off the demo gods. No, I'm good. So this is the environment that you write all of your Databricks code into. So this is the landing page. Common tasks would be to create a new notebook, upload data. Again, you don't have to upload data because you can use any data in Azure, but if you want to play around with data in the environment, you might want to upload some data there. So you would need to create a reference to call any data that you have outside. If you did want to use data directly from SQL Server, you would need to use the data gateway. And I believe on the data gateway, I believe you have to have an enterprise license to be able to use a data gateway, which is kind of cheesy. But that would allow you to directly access data that was on SQL Server. If you don't have that license, of course, the intermediate step you could use would be to put anything you want to in blob storage and then access the blob storage directly, which a lot of people do because blob storage is super cheap. Yeah. Did I just start the 2-hour period before it closes? Well, the first thing that you need to do when you're doing Databricks is to create a cluster. So this is the cluster that is running, and this is the cluster that is only running for 2 minutes. And that was a great question, because it's the first thing I actually wanted to do, because when you're in Databricks, the first thing you have to do is create a cluster. I've got one running already, but I want to show you how to do that. So I'm going to go ahead and say create cluster. And when you first start out, this is the first thing that you need to do, because if you don't have a cluster, then you don't have any place to put data, and you don't have any place to put notebooks, which means you can't create them. And if you read the documentation, it's not obvious why your stuff doesn't work, because you had to create a cluster first. So remember that part of it, because it's and I need to find. So I'm just going to do this new cluster. This also takes about, if I'm doing a demo, 15 minutes, but generally speaking, 5 minutes at least to create the cluster. So again, I'm going to show you all the steps and then say, I already have one running, so that we don't sit here and watch it spin. The cluster mode, you have high concurrency and standard. High concurrency, you use more for streaming. I generally use standard. The Databricks runtime version, I generally use the default, which is the latest version that they have created. If you want to go be really adventurous, they do have beta versions available. I told you that they have a new machine learning version that is doing more to monitor machine learning processes. That's what these ML betas are. So if you want to use those features, that's what you would need to do. It will automatically select the Python version 3 for you. When I first started doing this, they defaulted it to 2, which is pretty funny since that version is deprecated. You do not have to select your version of R or Scala, but you do for Python. And this is where you have this 120 minutes. So this is where where it's going to run for 120 minutes or not. Now, of course, I could change this to whatever I wanted to. I could make this 20 minutes. I could make this 300 minutes. It's just the default is on 120. And this is what needs to be running so that I can do anything. This is how I limit the amount of resources that I'm going to be using. The worker type. Remember I said earlier that different data centers have different types of storage capabilities and clusters, and so you needed to know that before you even started. This is where it matters, because if you look at the different worker types, you'll notice that, for example, this was created in West US, And in West US, I don't have these specific standard data clusters available to me. Now, I don't care for what the work that I'm doing, but if you're doing some in high intensity work and you want some of these different resources, then you would need to look in advance to see which data center has them, so you'd be able to select them here, which is kind of backwards because you had to create the Azure Databricks resources first, and then you get to here and find out you can't do what you want to do and you have to go create another Databrick again. So just keep that in mind if you do want to use high-end resources. And this is where I select the number of worker nodes, min and max. The reason I have this warning is because I don't have enough CPUs cores left on my account because I've kind of burned through it doing some stuff. So the minimum you can do is 1 and 2. And if you do this, the chance of you burning through a whole lot of money, very, very small. Because even if you use the most highly intensive process, I think you'd be hard pressed to hit over $100 if you kept your workers to this small, because there's just you're not giving it resources to hang yourself with. So, and it tells me that I'm connecting, which is a very bad thing. I hope this doesn't mean that my internet's gone. And then I'm going to look at the advanced options. And I can enter a Spark configuration if I already have one. And if and I don't need to do that, so I'm going to leave that alone. It's also logging is a beta that it just started, so that you can log your stuff now. Now, when I'm ready to create this cluster, so I would give it a path for where I wanted that log. If I just hit this Create Cluster button in 20 minutes, well, anywhere between 5 and 20 minutes, I would have this cluster that I could start doing with Azure. So pretend that I did that.
Question.
Yeah.
I believe that the Python version is 3.5, the highest available.
Yes. Yes.
And with this init script, I can upgrade manually by myself this Python version to 7 or whatever.
Right. So this is just basically 2 or 3. So if the version after that, you can pick later on. Because you can pick that in your notebook. So you can definitely use a higher version than 3.0.
It's still supported, no problems.
Yeah, it's still supported. So that's the thing about the different workspaces. Whatever version of Python that you want to use, you can. So if you have, but you have to do it by cluster. So if you wanted to create a 2 cluster and you also wanted to create a 3 cluster, your 2 cluster could be running 7.9 is the highest one. And then your 3 cluster, you could have multiple clusters. You could have one cluster that had like 3.3, one with 3.5, and that would be fine, but you would need to have separate clusters if you wanted 2 and 3 to support that. Good question.
Any problems with R versions?
Are there any problems with R versions? No. The reason that it does this, and you can use, this isn't a question for Scala, it's just the background for R and Pythons. And this is kind of an initial things because later on, when you get to notebooks, that's when you specify given versions of R, Scala, or Python. This is just 2 or 3. So it's kind of weird that it does it that way. But once I have this cluster created, and I'm going to go ahead and go to clusters, this is my active cluster. So this is what it's running for 2 minutes. And actually, I know when I started this, so it's going to stop right after this session. And this is going to be running the entire time so I can do stuff with it. You'll notice I've got all of these little bitty clusters down here. These are all of my job clusters. I have obviously you can see I've got a running job that runs every day at 4:20 just for fun. And that job creates its own cluster, runs the job, and then terminates a cluster. So you don't have to have a cluster running to run a job. You can include that in part of the management so you don't have to deal with that ongoing. So it creates a cluster, runs it, shuts a cluster down. And so all of these job clusters are gone. I don't have access to them after they're run. But that allows me to not have to have it up. I know if you've ever played around with Hadoop, if it's not up, then you can't do anything. This can make itself spin up and then spins itself back down. So that 2-hour limit doesn't impact your jobs. So once I've got a cluster created, I'll take a look at this cluster. If I want to just stop it, it says terminate. I really hate that. It makes it look like I'm going to kill the whole thing. It's never going to come back again. But no, to stop this, I would just say terminate. And then when it is not running, obviously it's running now, this button changes to start. And you just start it up, and it takes 2 to 3 minutes to start. So once I have a cluster created, then I can do things like go ahead and load data to it. So these are the data. This is some data that I have loaded to my cluster just so I can play with it. Again, I wouldn't necessarily have to do this. I could access my code directly, but I have selected to do this. And I'm going to go ahead and just create a blank notebook. And this is where you can pick your language. Notice you can, even though it made me pick a specific version of Python, I don't have to just use Python. I can use Scala, SQL, or R. And it's telling me, and I can pick what cluster I'm running on. I only have the one cluster at the moment, so it's going to only run on that one. So I'm going to go ahead and just do this new starter notebook. Oh, by the way, if you are familiar with the way that Jupyter Notebooks work, this is just another one of those. It's nothing special or unique about it. It is just a Jupyter Notebook. If you want to get more familiar with Jupyter Notebooks, I do have a video that I did for a past webinar session that was just all about it. So you can learn more about Jupyter Notebooks. But if you wanted to, what's nice about Jupyter Notebooks is it allows you to go ahead and take a look at the data and the code at the same time, and you can also pass them to other people. So I could do something like this, where I am selecting from one of my data sets and just going ahead and showing that. This works similar to SQL Server in that you have to execute it for your code to work. So I can just go ahead and run this cell, and it's going to go ahead and select my data and show it to me. So that's just data that I have loaded. It's loaded into a flat file, but I can run SQL against it to see the contents of my data. So anyone have any questions per se? I didn't realize that was going to be such a problem. So the idea with the environment within Jupyter Notebooks is Azure Databricks is your environment for creating code. That is where you would write your code, test it, use the data within it. Yes. And that and you do that environment. Now you don't have to write your code there. You can write your code somewhere else. It's a Jupyter Notebook. You could create a Jupyter Notebook somewhere else, upload it to Databricks. So if you're worried about, say, if I'm generating a big Azure bill here, and then upload that IPyMB file up to Databricks and run it there, you just need to change your data connections to where the data was physically loaded. So you can automate this process with jobs, and I wanted to take a look at doing that. Databricks jobs are very similar to SQL jobs, and you can run the code in your notebook on a schedule. And it uses an existing cluster. You can make it do that if you want to do that, but I don't recommend doing that because that gets to be expensive. You have to leave that cluster up all the time. It's more efficient to create a cluster and run the job in that cluster on the fly. Databricks jobs, multiple people can own them. So, and you can send out status notices, similar again to SQL jobs, based on the status of it. So if the job crashed, if the job took too long, if it was successful, I hate it when people send those out. Really? I only want to know if it's busted. And you can do retries. It will do different retries based on what you want. So do you want it to notify you if you want to try 3 times before you give up? You can do that. And you can define your scaling options as well. You can say, well, I want this to scale. I want this to scale in a significant way for this particular job. So you can control that as well so that your job can run more rapidly if that's what you want to do. So you can also do things that are what's called structured streaming. And structured streaming is what's used for a non-batch but more of a real-time job. So if you're streaming data like the IoT data that comes with it, it integrates with Kafka, so it's processing chunks in near real time. And you can then have interactive status metrics. If you've got a scenario like that, that's when it makes sense to keep your cluster up all the time because you're streaming data into it. And doing the structured streaming to get the data that you are running. You can also, one of the other big use cases for Databricks is doing deep learning. Deep learning is a different type of machine learning that tends to be extremely resource intensive. It natively supports TensorFlow, Keras, and CNTK. If you've ever done any development with these tools, they take hours because of the multi-level node processing that they do to establish results. And that is another great use case for Databricks because you can throw more resources at it to solve that problem. And that'll allow you to create neural network machine learning processes. So if you're into doing that, it's a big time saver because those things are such pigs. So let me go ahead and show you some more Databricks code and demos. So I fly quite a bit, so I'm interested in airplane crashes, morbid curiosity. And what I have done is I've done some analysis of a airplane crash data set that shows a whole bunch of airplane crashes since 2008 and gives you an idea of how many people died and how many people were aboard. So I went and uploaded this particular data set. You can see as a CSV. I've uploaded that to... Oh, great. See extended screen time? Well, what I'm seeing behind me is nothing but spinning. So what I've done is some analysis of that and created a Python job, and then you can go ahead and run that Python job using the job sets, which I wanted to show you. Maybe. It's funny because I took it off, put it on duplicate so that I wouldn't have this problem, and then I went to extend. But now it's telling me I don't have internet. That's not so good. Not a whole lot I can do with an Azure demo without internet. So what I can do is I can take any job that I have written in Python, once I can call it up, and create a job that I can run on a periodic basis and set parameters to it as well. In this icon here, which don't point in me clicking if I don't have this resolving. Let me try this one more time. Oops. So it's connecting. In this area is where you set the various account permissions. You can add users. You can give different users rights to different workspaces. You can have someone who has access to the Azure in the Databricks environment, but not everything within it. You can have different categories that are subdivided off. Yes. All right. So I did the first step here. The next thing that I can do with my code here is I can go ahead and do some looking at the schemas. Ooh. I think it just, when I crashed, I think it might have dumped my connection. All right, let me try this again. Come on. All right. So once I've got this loaded, I can go ahead and look at the schema on it. And I can also do some fancier SQL. So I can look at, this is considered a magic command in Python. I can select airplane crashes where dead is over 150, or over 50. And when I do that, it formats it better. So it's more of a SQL-like format. I can just display how many people were dead. I can also do some pandas command. And within this, I can load any Python library that I wish. So if I wanted to load any kind of an updated TensorFlow, a new Panda, I can go ahead and reference that the same way I would do with Python code. And then I can do something fancy, perhaps run something in Seaborn and get a pretty looking graph. Oh, come on. Let me do this first. Can't do things out of order. You'll notice that with the previous Jupyter notebooks, I have the results beneath my code. All right. So I can do a kind of a pretty little graph there. All right, to create a job with this, I'm going to go ahead and look at the admin console. So if I do this, this is where you add the different users that have access to it. And I can look at, I can create groups, workspace storage so that I can purge it, purge revision history, cluster logs, and add different people there. I can manage my account, and managing the account will pop me back into Azure to allow me to manage it better that way. And I can go ahead and create a job. So I'm going to go into jobs here, and I can create a job. Now I have to have something to create, so that means I need to have some existing code that I have compiled into a notebook so that I've got something to run. Once I do, I can go ahead and create a job. And I'm going to go ahead and give this a name. I can select a notebook, a jar, or configure a Spark submit. So I'm going to select a notebook. And I can pass parameters to it if I wish, or I can tell it to run it now. So I also have the ability to schedule it. So if I go into schedule, I have a number of different options. Again, this is a lot like a SQL job. I can select every hour, day, week, month, starting at a given time, and I can do different types of cron syntax. So I'm going to do this, let's say every day, and I'm going to start it at 8 US Pacific, say confirm. And then I can go into advanced, and this is where you get into my alerts, so that I could add emails to this on start, success, or failure. And I can choose not to send alerts for skipped runs. I can also select my timeout. If it takes forever, I can specify my length in minutes for how long it needs to take, and the number of retries. So this isn't Orchestrator. This isn't the most flexible job thing in the world. If you want more flexibility, more interactivity, I would highly suggest running this in ADF, but you don't need it. If this will work for you, if you just wanted to run something every day and you're confident that the file is going to be where you need it to be, then you can go ahead and use this and not have to integrate with any other tools. So you can, but you don't have to. You're not forced to do that. And it will let you know if it's going to die on you.
How would you run or launch this job by some event, like creating a new blob file?
How would I do it how would I want a job to run if I'm doing it with an event? That's when I would use Azure Data Factory. And so like first step would be like move data. And then once that step is complete, then I would, the next workflow step that I would do would be to run a Databricks job. So if I had dependencies, that's what I would use ADF for, because it'll handle that. Because this isn't what this will do. You'd have to write the code to say it's a file there, versus if you did it in ADF, it wouldn't run it until it was there. So if it helps you get a little bit smarter with your runs. And then what it will do is it will run when it'll spin up a cluster, and then it will end the cluster. So if I look at my jobs that I have created, I think this is the one that I've got. It'll also show me my output. I wanted to show the one that I run every day, and I don't think this is the right one. But you can see your output for every single job that you have run as well. And the one thing that you also, to your point, if you run out of Azure money, your automatic job running thing will die. So if you have restricted it to only use a certain number of clusters and you don't have enough resources, it will say that you don't have enough resources to run this query and it'll die. So that can be, I want it to do that because I don't want to go over. Obviously, you can change that setting so that you won't have to deal with that.
What if we, for example, create a job to run every 3 hours and we have also set up this setting to shut down every 2 hours?
So what this is doing though is it creates a cluster to run in. So it spins it up, runs it, spins it down. So it's you do not have to configure your jobs that way, but generally speaking, that's how jobs work. So it's not going to run in that 2-hour window. You'll notice that it's just doing these runs in Spark in Spark UI. So this ran yesterday, and it is just running on a cluster that gets created for this job. So it's not running into that 2-hour window. Although when I wrote this and created it, I did use that for initial cluster that we were working in. So I can write it in one cluster and run it in another. You're not limited in that way. So it tells me that it ran this and it ran this every day, and it gave me my output. Kind of a simple process. But does anybody else have any questions?
I understand that the job when it starts, it spins up the cluster. Yeah?
When the job runs, it spins up the cluster. Yes. And it'll just spin it down when you're done.
So it's the same way how it works with Azure Data Factory when we execute the Databricks element in there?
It works the same way in Azure Data Factory when you do the elements within there because you're running a job. So you're running a Databricks job, which means you would need to create that Databricks job and then call that job within Azure Data Factory. Good questions. All right. So in summary, Databricks is really flexible. It's designed for doing machine learning and other iterative processes where you're taking a bunch of things and putting into data at the time. It's very extensible. You have the ability to use different libraries, use different languages, and you can do scheduling with it as well. And does anybody have any additional questions that you haven't asked? I do have a couple of posts on this on my website as well, if you do have any additional questions. I will say that the documentation that Databricks puts out is really quite good. Again, this isn't Microsoft product, so you need to go to their website. They also have some pretty informative webinars that they schedule periodically. Once you get signed up with them, they never stop sending you email. So if you're interested in learning more about Databricks, try learning it from them. And one thing that's really kind of cool about this product is while it's in Azure, it's not a Microsoft Azure product. So if where you work, if you use AWS, you can use it, or if you switch, you can still use it because the tool is available on either environment. So, well, that's it. Then thank you very much for coming today, and I appreciate talking to my first group of Polish people. Yay!